square root of xy minus x2 squared plus y.
So, if you have a vector A that has components of 5, -2, can you draw that vector? And can you find its magnitude? Go.
Find the vector and magnitude. Okay.
Draw the vector. If you have grid paper, it works out nicer. Is that how you drew it? Is it kind of going down?
Oh, -2. I thought I was positive.
So that was the negative, yeah. Fine. So you got 3.5, or actually I really like square roots. What is the magnitude that we were to write?
Square root of. I also drew the opposite vector
Why?
because I thought that was positive 2, not negative.
Okay, I'm going to tell you, those aren't opposite vectors.
But they have same distance. The magnitude is not the distance.
Well, okay, you didn't go over. Okay.
These two are opposite.
Okay, so if you drew a vector that was here, so if you have vector A that is 5, -2,
Yes.
vector will say B. What are its components?
5 and 2.
Are those opposite vectors?
I don't know.
No, they are not.
Is it -5 too?
Okay. They are not. They are equal vectors, meaning they have the same magnitude.
Okay.
Okay. But they are not opposite. They're not going in the opposite direction.
Oh, opposite direction.
Okay. So, little hint: if you were to add vectors, if they're opposite vectors, you should get 0, 0. Okay. If we were to add right now, it would be -5, +2, right? So if I were drawing the opposite vector, let's make it a different color. It
So,
would be -5, +2.
so each
Light that I'm trying to hit at that point.
so each vector only can have one opposite.
I don't know why it doesn't want me to hit right at that point.
Is that correct?
Mm-hmm.
Okay.
Why won't it just go? Never mind.
It's okay. We don't want to.
Okay. The opposite vector, can we say vector C? What are the components of vector C? Pretending it is in the same spot. -5, +2. So if we wanted some resultant vectors, what is a resultant vector? Well, you didn't. I've got 3 vectors up here. What does it mean to have a resultant vector?
Two
Sum.
together.
Result.
You add vectors.
You can add vector. If I ask you to add vector
Can we
for A
can
and B.
yes. I have a question.
Yeah.
Can you add 3 vectors or 4 vectors? As many as you.
Technically, yes, you can. And it's not saying can I add more than 2 numbers together.
Yes.
Yes, you can.
Thank you.
So if I add vector A plus vector B, what do you get? What is vector A?
10 or 5, 2.
5, -2. Vector B?
5,
5, +2. So our resultant vector is?
2. 10, 0. Yay.
Okay. How can we illustrate that? How can we illustrate that visually?
You put B like at the terminal point. You put the initial point of B at the terminal point of A.
So we want to go this way. We want to go over 5. Is that 5? Down 2?
Yeah.
Okay. That is another A vector. Okay. These are the exact same. Okay, I don't know what they're the same thing. Could I have done terminal point of A and added B? 1, 2, 3, 4, 5. I don't think I went over 5. Up 2. I didn't. And now I'm not going to be able to change it. You know what I'm going to do? I'm going to delete it. And then I'm going to put the correct one there. 1, 2, 3, 4, 5, down 2. And what do we have? A parallelogram. I have a parallelogram, and what is my resultant vector?
10, 0.
10, 0, which is
The
a diagonal of this parallelogram.
Yes.
Okay, so we kind of tied into that last problem that we did in 7.3,
What is that?
which was a parallelogram problem. You had to find the length of both diagonals. Okay, so yeah, that's why we're doing this. Okay, so we know the components of all of them. Okay, so we can add things together. They talk about in vector, because vectors are kind of just a little different. They talk about scalar multiplication. If you hear the word scalar, it just means a number. 2, 3,
1, 2,
7, any number. Meaning, can I double the length of a vector?
Yes.
I can. If I wanted to double the length of C, you double the X and you double the Y. So if we wanted to say 2 times vector C, it would be
Negative 10.
-10,
Positive 4.
+4. And we can just double the length of it. Okay? But that would be the component. Scalar multiplication is not hard, just multiplying a constant number times the components of a vector. Okay? Yesterday we did a lot of the magnitude, finding the distance. Okay? All of these, A, B, and C, do they all have the exact same magnitude? Because we've not used any numbers other than a 5 and a 2. A -5 and a -2 maybe. Is the magnitude all the same?
They're all the same.
If the numbers are the same,
The numbers are the same, they're all going to be the same. Okay? Didn't matter which direction we were going. So today we're going to start talking about direction. Okay? And there's a formula for direction.
Square root.
No. Not a square root. I really don't like
that is distance.
magnitude, distance, and square root. It's in a little box.
Which page?
I don't remember.
Right. That's fine.
Let's find it. 7.4. I'm on page 335. The magnitude of vector U. It's all about magnitude and direction of an angle. Direction angle of a vector. It's in a little green box.
This time is in.
Yes. Yes. Magnitude, so they'll write like a U with a this equals that. Okay? But the direction, the theta, the angle theta that satisfies will be tan theta equals, and I'm not writing B's and A's, X, and Y. So it's Y over X. Where X cannot equal 0.
How?
Is that
Why? What happens if X is 0?
No. I mean, why do you use two?
it's undefined?
Because you're gonna have an opposite over adjacent.
Yes.
It goes into so many things. It's the slope. What is tangent to the slope? What?
What?
Rise
over.
Why
Rise over run. It's the change in Y's over the change in X's.
No.
What? Are you telling me you don't know that or you don't like that?
I don't want
Okay, I can handle you not liking something.
So that's
So it's the theta. So if you wanted to find theta, really you could rearrange and say theta equals inverse tan of y over x. If you have your components of u that are x and y. In the book, a lot of times they use a's and b's. It doesn't matter. Yes. I mean, there's a time that I used U's and B's, and I had a kid say, no, not using U's and B's, I'm just going to use A and B. Whatever floats your boat. I really don't care. Whatever goes your float. Alright. So, phasing goes. We talk about phasing goes a lot. And then, alright, do we want to find we need to find a one, don't we? So here we go. Formulas that you need. So if you have a vector, let's go back to our vector. Let's do a different one. Gonna grid. Here we go. Vector that's gonna be. There you go. There's a vector.
Okay, I have kind of a dumb question. Whenever it says find the direction, like,
It's an
can't
angle.
you just say like
Northeast.
it's going this? Yeah.
No.
But why?
Well, I mean, technically, if you're with when we will get more technical, we will talk about it in terms of northeast at an angle of. We will, in general, give it a direction that it's going.
So we find the.
What are we trying to find? I'm sorry.
Okay, but I didn't say. Let me. If this is vector u. Tell you what. Let's do two things. Let's find this. I think the book said find the magnitude and direction of vector u. Find the magnitude and direction means your theta for vector u. First, you have to do what? Find the components, draw the origin. So u is going to have what components? 1, 2, 3, 4, 5, 6, 2. So magnitude is simply going to be the square root of 6 squared plus 2 squared.
Do we have to break square roots down? At this point?
There's a huge question. Are you ever going to leave a fraction as 4/8? I won't let my pre-algebra kids leave a fraction as 4/8. So no, you can't leave a square root of square root of 40.
Is it degree mode or radian or normal? Degree.
Degrees.
Yes.
We're going to find our thetas in degrees.
Okay.
So what did you get for your magnitude?
Oh.
That's what you got for your magnitude. I just said, can you leave it like that?
So 2 on the square root of 10.
2 on the square root of 10. What is your direction? What do we do? What was our formula that we just had?
Oh, I'm sorry.
So theta equals what? Is it regarding tangent of y over x?
How many do you just want us to run it to the 10?
Probably say
Sure. They give me a decimal place.
18.
So we got what? Oh, stop. Does it make sense that it's 18.4 degrees?
No, it doesn't matter.
Where are we measuring from?
From
From
the bottom.
the bottom.
From the initial point.
From our angle right here.
So it's still
18.4
18. But if
degrees.
it's in the second quadrant, you need to use 180 degrees.
No, it's going to go over. That's how you're going to know it's in the second quadrant.
I mean, if it's in the second quadrant and you get 18.4, you need to use 180.
You should not. You should not.
Oh.
Do I have to memorize? Yes. You need to know that it's y over x. Tangent theta equals y over x.
Oh, I changed to second quadrant and I got negative 18. So.
That's our direction.
But it gives you degrees.
Yes.
Oh, okay, yeah, that makes sense.
Yes.
So
Does it make sense?
it can give you like, well, would it ever give you negative?
Would it ever give me negative degrees? It could.
Negative 274.
Probably not. It's probably going to give me a negative. Oh, you just went this direction. No,
Yeah, that's-
your
that's what I'm
calculator's
saying,
not going to do that.
Like, is there any chance that it would?
It shouldn't. Your calculator's not going to do that.
And
What happens if it's in the third quadrant? No. What happens if it's in the fourth quadrant? Can it give you a negative angle? Will it give you a negative angle if it's in the fourth quadrant?
Yeah.
So if you get a negative, it will put it in the fourth.
and
What happens if you know it's in the third or in the second quadrant? So here, let me give you another. Can I give you another vector
Yes.
on the same? Can I use the same grid?
Yeah.
Oh, why am I on the circle? Because I'm not using the same thing. Here we go. There you go. Small, nice numbers,
Can you not
vector.
do 2 anymore?
Say that again.
Can
No.
you like 3?
Sure.
Shake it off.
Get wild. Oh,
There we
wow.
go.
There we go.
I'm getting me crazy, Miss Evans.
Vector R. Initial point, terminal point here.
What's the component? Oh, we need to find it.
So what are the components of R?
Negative 5 and negative 3.
So you found components. What are the components?
5 and 3.
Positive? Did it go positive 5 and a positive 3?
Yeah.
No, because this is my initial. That's
Oh,
where the
oh,
arrow
that's your
is.
initial?
I didn't see an arrow.
I didn't see the arrow.
I have a question.
Okay, so stop. looking at, it's in the third quadrant. The initial point is where it starts. The arrow is where it ends.
Alright, -5,
-5, -3.
I mean, you're gonna get the same thing.
You're going to get part the same thing. So your magnitude should say the exact same as whatever you just did. So what did you get, Molly? We all get square root of 34.
Yes.
Okay. Direction. What did it give you for direction? 31 degrees. Does that make sense?
No.
No, it doesn't. Why?
It's in the third quadrant.
Because it's in the third quadrant.
So just add 180.
So this you got was 31 point whatever because it's positive in the first quadrant. But where else is it positive? The third quadrant. So we're going to add 180 to that because it makes that straight line. Okay? So you're going to get whatever answer you got plus 180. Now, can I tell you something that is wonderful and nice?
Sure. I love to hear something wonderful and nice.
Okay, never mind. I hit the wrong buttons on my calculator. But here we go. Let's pull up the calculator because I put it down again. I had it up a lot yesterday, but I need to show you something that will change your life forever.
Change my life forever.
These are easy. You can get to these anytime.
Wait, why is there a camera? I'm going to take selfie.
Okay, does everybody have the okay, you need to be able to see the answers from the last problem, yes? Okay. There's a button. Everybody got your calculators out.
Yes.
Okay? If you hit second angle,
Angle.
okay,
Okay.
which is this little button right here, it's the apps button,
Yes.
okay, and you go all the way down to number 5,
Okay.
okay?
What does that mean?
That is, I don't know what the letters stand for,
Okay.
but it's for the vectors, for the magnitude.
Okay.
If you plug in 6,
6,
comma, 2,
2.
in parentheses, comma is right beside x squared.
And we got 6.32.
Okay, you get this number. Okay? You got, well, I'm doing this one. I'm doing this one the first. So this was the square root of 40, right? Which is 2 root 10. So 2 times the square root of 10, plug that in.
They're the same.
Are they the exact same numbers?
Wow.
Wow. Okay?
What mode do we have?
No. We're all in degree mode. We're not changing anything.
Even this is
Error?
Yeah, I got an error.
You didn't put a comma.
Oh, I put a dot.
You're
You
right.
put a
I
dot,
did
you put
the exact
something different. It's a comma.
I did the same thing.
Okay, because I did that on mine too. It's okay.
Okay.
6 comma. So now, here, let's hit it again. Second apps. Go down to number 6, where it's the theta. Guess what the theta is going to give you?
Find the bed.
Okay. You're going to put in 6, comma is right above the 7. I'm hitting the buttons right here. The comma is right above the 7, right
Yes.
beside the parentheses. 6, comma 2.
Yeah.
Enter. Did you get 18.4 degrees? Which is exactly what we got.
If it's not in the first quadrant.
Now let's go put the one in you just did.
Okay.
This problem. Okay, so you've already added 180 plus 31 and gotten something like that, right? So let's go and put in.
I got a weird number.
So you put in
It would be
the RPR -5, comma, -3 in parentheses. 5.8 is that the square root of 34.
Yes.
Do you want our answer in decimals?
There will be times where it will say simplest radical or decimal. Okay? So you have to answer decimals or simplified radical. If you go back to second angle, go down to 6, -5, comma, -3.
Why?
Oh.
Why do we give?
Why did they give me the negative?
Because it comes from another direction.
They came from the other direction. I was hoping they wouldn't.
Why?
They
Why?
came from this direction.
Do you know
So
why?
do we just add 360 to it?
You can add 360,
Do you know
or you
why?
can say because your calculator is not as smart as you. They're never gonna give you any, really. It won't give you an angle more than 180 most any time. So this angle is -149, basically. So if I take that and add 360, I get that 210.9, which is the 211. Okay. What do we call those angles? What do we call?
Supplement. No. Which angle? Which angle?
This angle right here. That's this one. Really, it's this line. Okay. What do we call 211 degrees and -149? How are they related? They're coterminal angles. Okay. So you still have to be smarter than your calculator. Okay.
Okay.
You start to think, does this make sense? Okay? Calculator is a tool. Okay?
Well, that's a lot easier than doing math.
Remembering that formula, tangent theta equals y over x. Okay? You need to know what quadrant it's in and to make it make sense. Okay? So here are your answers. If it says simplified radical form, okay? Or it might say round to the nearest tenth, round to the nearest hundredth for magnitude. Okay? I'm going to go to another page and we're going to talk about what happens if I only have the magnitude and direction. Can you go backwards and find your components, that x and that y?
Yeah.
You can.
Just take longer time.
If I give you the magnitude equals something and the direction equals something, can you go backwards?
Yeah.
Of course you can. If I give you the magnitude of 14.5 and the angle, the direction angle is 220 degrees. On page 336, there's another wonderful green box. Page 336. There's a green box that says the horizontal and vertical components of a vector u having a magnitude of u and direction of angle theta are given by. They still use a's and b's. X equals the magnitude of u times cosine of theta. Your y will be the magnitude of u times sine theta. Why do you think we've gone from tangents now to cosines and sines?
Because you need my x and y.
So we're going backwards. We're dividing. What do you know? What did we talk about the unit circle the other day? And if we have a point x, that really is cosine of whatever angle. So your cosine is still related to your x's, and your sines are still related to your y's. Ingrained in our head from quarter one, it is not still there. Okay? So if I give you a magnitude of 14.5 and an angle of 220, can you plug that in and find what is x? It's 14.5 times cosine of Move that away. Cosine 220 degrees. And your y is 14.5 times sine 220 degrees. So plug those in. What do we get? X, y is 14.5 cosine 220. Of course, I can't read what it says. Negative 11.1. Do I need to be in component form? Do I need to plug in the next one? 14.5 sine, because sine is related to y's.
What is it? It's negative.
Sorry, it was negative. And it's negative 9.3, I think. Yeah. Does that make sense with a 220 degree angle? Which quadrant are we in? The third quadrant, 220. So we are all the way over here, 220 degrees. Does it make sense that our x is negative and our y is negative?
Yes.
Yes, it does.
Because
Because
it's third quadrant.
it's in the third quadrant.
Wow.
Okay?
And the
So-
calc can do all that. The calculator can do all that.
There's a button. Second apps. If you go all the way down here to the bottom where it says X, Y, so number 7, you go second apps and then number 7, and you plug in 14.5, comma, 220. Guess what it's going to give you?
What was he gonna give you?
Negative 11.1. If you plug in second apps, number 8, and you put in 14.5, comma, 220. Guess what it's going to give you? Negative 9.3.
So you put the magnitude first, then.
Yes. Magnitude and direction.
Okay.
That's what vector says. Magnitude and direction. Put them in that order. Yes, ma'am.
So number 5 on second apps has to do with magnitude, but then 6 is direction.
So, yes, 5 and 6. Okay? 5 will give you the magnitude. 6 will give you the direction. 7 will give you the x value if you're looking for components, and 8 will give you the y value of your components. That's that R's and P's and P's and R's.
Can you go,
I don't know which one of those why it means that. What do you?
can you go back? That calculator.
That? And it gives me that gives me all 10 digits are exactly the same.
Oh, they have RX and RY.
Because I went and chose that. Any questions? So if I give you components, you can find the magnitude and direction. If I give you the magnitude and direction, you can find the components.
Now, can we do another one for
Sure.
magnitude?
Sure. But you would need to find the magnitude,
No, where you can find
the x and the y.
the x and the y.
Alright, so if I give you another magnitude, the magnitude equals
This one, oh, it cannot be negative.
8.7, and the direction, let me just kind of make that into a theta. Theta equals
Fourth quadrant.
126 degrees. Go.
Does it matter which number you plug in first?
On magnitude or direction? Yes, it does. Because it's going to give you a different answer if you plug in direction first. So So think of vector. When he talks about it, he talks about magnitude and direction. It must be in that order. And logically, I hope you can look at that and know which quadrant it's in. Okay? So you should know which the x or the y value, which one should be positive, which one should be negative. Your magnitude always has to be. So what did you get? What did you get for x? Prince, what did you get for x?
I got
Negative 5. Is there a decimal? Negative 5.11. Is that what you got?
I don't know which
It will tell you somewhere. Round to the nearest. I mean, you need at least 3.
No, I mean for this one.
Yeah.
You want 3 or 2?
I generally actually like more.
But I know, but like it's
I'm not going to take points off for sig figs unless you're blatantly giving me 12 or not giving me any.
it's negative
5.11.
and then y.
Justin, what did you get for y?
7.04.
7.04. Okay, so when you plug those in, it's so simple. Second apps, number 7, 8.7, comma, 126. Negative 5.1, second apps, 8.7, comma, 126. Super easy. It's one of those why would we ever learn the hard way.
Because even the hard way isn't very.
Yeah.
Even the hard way isn't that hard.
Yeah.
It's not that bad.
Or
Yeah.
you're just
Hey, knowledge.
Alright.
I like it.
I'm just
I'm looking for it.
I think we've got everything. Oh, I think I see you guys for like 20 minutes tomorrow.
Only 20 minutes.
I think so. Okay.